Okay, Assalamualaikum warahmatullahi wabarakatuh. A very good day to all. Okay, so in this class, I'm going to continue with chapter 4, if I'm not mistaken. So this chapter composed of vector. So this chapter basically we focus on the evaluation of the vector. So we are aimed to provide or to give simplification of the vector at the end of this chapter. But in this video, I'm going to cover the basic operation on the vector function. Okay, so here, first one, I'm going to uh, we are going to look on the vector function operation. So basically, we are going to recall again what is the dot product, what is the cross product, and so on. And next one, we are going to look on differentiation of vector. So basically, we have done the differentiation on multivariable function. We have done the partial derivative on higher dimension, and in this video, I'm going to show you how you can differentiate the vectors. And next one, we are going to continue with the integration. Of course, to compare integration of this chapter with the previous chapter, this chapter which be much more simpler because we are going to cover only one variable vectors only. Okay, and then we are going to compute and we are going to look what is the definition of tangent, unit tangent, and also unit normal vector. So first one, we are going to recall again the basic operation that we have in the vector function. So basically, these things you already learned during engineering mathematics 1. So for example, here you have addition of this one. So you have addition of two vectors. So given a two vector, you can add the two vector according to the coordinate I, J, K. So basically in this class, we are going to cover up until 3-dimensional setting. Okay, so you are going to have I, J, and K vector component to I, respect to component I, respect to component J, and also with respect to the component. Okay, so to add these two vector, what you have to do, you need to add uh, corresponding to each of the component. For example, i's with i's, j with j, and k with k. And next one we have f multiplication of a vector with a function f. So you can multiply each of the component with function f one by one. So for example, you can multiply component I with ft, component j with ft, and then component k with ft. So next one, the cross product is given by this thing. So we are going to look again what is the definition of cross product and also what is the definition of the dot product. So these are the things that you already learned during your engineering mathematics 1. So therefore, I'm not going to go to a very detail. I know that you already learned about these things and you should recall again or you should remember. So basically, I want to say that you already has experience dealing with this thing. So therefore, I believe that you can do if I give you a question on regarding to this problem. Okay, first of all, first let us look on the example given here. So let's say that if we are given f is equal to 2t minus 5j and t square k. So in the soft copy, I can bold the vector. So here is this is the way that I write a vector in soft copy or in the PDF here. So I can bold F, I can bold J, I, J, and also K. So this bold things means that it is a vector. It is the same with your final examination. If we bold these things, means that it is a vector. For example, G, I, K here, H, I, and J here. All those things are vector. So now we have three vector, F, G, H. Now first one, we would like to find T square Ft minus 3HT. So in writing, I'm going to write um, arrow in above of the alphabet here. For example, F, I have F and I put the arrow like this. So it means that F here is a vector and T over here is a variable and 3 over here is not a vector but it is a constant, and also H here will become a vector. Okay, so in order to compute this one, what we are going to do, so I'm going to write T square and I'm going to copy everything Z from here is from f of function, sorry, vector of f. So I copy everything over here to put it inside here. The same happen in this case. So I copy everything from the h and put it here. So that is the I believe that everybody can do this one. And then you can open the bracket one by one like this, and this one. So here we have only two vectors, and then here is a product of the first expansion, and this is a product of the second expansion. So now what I'm going to do from here to here, I'm collecting mm, the same component. So I collect the ith component with the ith component. So what do I get? So 2t cubed minus 3 sine t. So that's why I have this thing. So next one, I collect with the component j. So I take it negative 5t square minus with the negative 3e t. So here we become the jth component. And kth component, we don't have any pair, so you just copy everything. Okay, so this is the first question. Second question is about the dot product. So recall here, the dot product is defined by the following way. So I copy this is F and this is my G. So sorry. So this is my F and this is my G. So copy everything, and then how do we multiply a dot product is by multiplying each of the component. Ith the component with ith component, j's component with j's component, and kth component with kth component. For example here, so ith component over here, we are going to multiply with ith component over here. So this 2t minus, oh sorry, 1 minus t. So this is become our ith component. And you have to keep in your mind, please do not copy or please do not bring together I, J, K component. So you see that here, I just multiply the coefficient in front of ith component and also over here. I did not copy the I, vector I over here. So therefore, our final result should be a scalar. Uh, so not a vector anymore. So we have here 2t, 1 minus t, and then this component with this component. So over here, we have negative 5 But over here, we don't have any jth component. Means that jth component over this side is equal to 0. So that's why we have negative 5 multiplied by 0. And the last one is the kth component. We have t square. So t square, I'm taking from the left hand side of the kth component, and the left right hand side is a 1 over t, and put it here and simplify everything. So open the bracket like this. So negative 5 multiplied by 0 equal to 0. T square multiplied by 1 over 3 is equal to t. And this is the final answer. Okay. So next one, here is the cross product. So the cross product we have is defined by the following way: F cross H. So this is coming from your F, and this is coming from our H. So if we recall again, H is equal to, we have only two component, I and j, and means that kth component is equal to 0. So that's why we have, this is i's component, this is j's component, this is kth component from the H vector of H. So if you don't have any component for kth, so means that the component, it must be equal to 0 over here. Okay, so substitute everything. So you have to follow. First, you need to write F. Second, you need to write H. So you cannot interchange the cross product. So, and keep in your mind, you have this symbol plus, minus, plus, ijk. So plus, minus, plus. So I'm going to um, expand this cross product. So how do I expand here? First one, I'm taking the ith component. So put it over here, and then just imagine that you are, sorry, just imagine that you are you are what we call closing the first row with the first first row and first column. So this is row, this is a first column. So we are going to left with this one. So just take everything and put it here, and do the same thing. So this negative, take it here, and j, copy and over here, and do the same process. So I mean that if we are taking j now, so means that we need to close the second row, second column, and the first row. So means that we only have 2t, t square, sine t, and 0, which is, this is our matrix. So same process is the case. So taking the positive, here we have positive, and copy the k. So means that we need to close the third column with the first row. So mean that we have this matrix. So expand this matrix like you calculate the determinant. So here multiply and then minus with this one. So I have negative 5 multiplied by 0, this one, and then minus, don't forget that one. So t square multiplied by et. So we have t square multiplied by et. So this ij is coming from here. Okay, so do the same process with the next component. So I just copy negative. So I just copy the negative over here, and j, I put it at the end here. And then what I need to do, expand the determinant here. This one multiplied by this one over here, minus with t square multiplied by sine t. So repeat the same process with the third determinant. And last one, you can double check everything and simplify to have this answer of the cross product. Okay, so last one you can do on your own. Try to find the answer. And one more thing that you have to keep in your mind, the dot product give you the scala or there it give you a scalar or a function. For example, in this case, we have a function. But for the cross product, the final output must be in term of uh, vector. So means that it has i's, j's, k's component for the cross product. So dot product, it is either scalar or function. Cross product, it must be vector. Okay, so done with that one. Now we continue with the differentiation. So for a given f, then the derivative is defined by the following way. So it means that to find the derivative of f, what you need to do, you just find the derivative of f, g, and h one by one. So if you want to have, or if you want to find the higher order of derivative, for example, second order of derivative, so double integral of this one means that you need to find the double integral of f, g prime, g double prime, and h double prime. So it is similar process to what we learned previously, except we all have the i's component, j's component, and also k's component. Okay, so note that 1 and 2 is also applicable to compute the partial derivative. So the same rule that apply over vector here. If you have a vector more than one variable, then you can find the partial derivative using the rule given by 1 and 2 here. If you want to find the partial derivative in respect to u, for example, let's say that the function is defined over u and v. So you can treat, if you want to find the partial derivative respect u, then you have to treat v as a constant and do it one component by component. Okay, so find the partial derivative with respect to u over here, respect to u over here, and also this one. And treat v as your what we call constant. Okay, so let us look example over here. So let f is given by this one and find f prime. So like I said before, to find the f prime, we need to find the derivative each of the components. So the ith component, jth component, and also kth component. So therefore, the derivative of 3 minus t, uh, 3 minus t, so it is equal to -1. And the derivative of 2 is equal to 0. And last one, the derivative of -4 plus 3t is equal to 3. So here is a final answer, -1 plus 3. Okay, so of course you can stop the video and try to do on your own if you don't understand. Okay, so the key point that you have to understand here, to find the derivative of a vector, you just need to find the derivative each of the component, s, j, and k. Okay, so here the same example. To find the derivative of f prime t, the derivative of 3 sine t is equal to 3 cos t. Derivative of 3 cos t equal to -3 sine t. So it is equal to 3 sine t. And 2e3t is equal to 2, x6e3t. Okay, so I think that is simple. Uh, and here is a higher order derivative. We need to find the derivative, the double integral at t is equal to 0. So therefore, first we need to find the first derivative. So to compute the first derivative, I think there is typo over here. So it should be first derivative. Okay, so this is the question. And to find the first derivative, as usual, we are going to compute the derivative each of the components. So to compute derivative of this part is equal to 4e to t. and compute the derivative of this part is equal to 4e to t, negative 2t, because we need to differentiate this part. So negative 2 multiplied by negative 2 is equal to positive 4. That's why we have positive 4 here. And last one, what we have here. Oh, sorry. My mistake here. So I think the previous one is already correct. So this it should be double integral. So actually I already compute the first integral over here. Sorry. So this is the first derivative. Sorry. So from here, derivative of e to t is equal to 2e to t, and derivative of e negative 2t is equal to negative 2e to t, and derivative of this part is equal to this one. So keep in your mind, we have t, we have 2t here. So therefore, we need to use the product rule. So the product rule, how to use the product rule? So I copy t first, this t, and differentiate this part. So differentiate e to t is equal to e to t, and then copy this one over here and differentiate t. So differentiate t is equal to 1. So no need to write 1 over there. Okay, do the same process to get the double second derivative. So differentiate this part to have here, this part to get here, and this one to be here. So you can do the derivative by yourself after this, and try to do on your own to get the feel how to find the derivative. And then last one is to substitute value t is equal to 0. So here I want to stress, you cannot substitute the first derivative you cannot substitute t equal to 0 in the first derivative, and then you use that first derivative to compute the second derivative. No, it is cannot be like that. Because if you do like that, uh, you put the t equal to 0 in the first derivative, second derivative you are going to get 0. Everything will become 0 because you already substitute value, and everything will become a constant, and the final output of second derivative, of course, is going to be 0. So the correct way is to find first derivative, to find the second derivative, and then you need to substitute at the second derivative. That is the correct way. So substitute everything at the second derivatives over here. So e of 0 is equal to 1. This is also equal to 1. So we have 4. 4. And over here, this part becomes 0. And this is equal to 2. And here is the final answer. Okay. So I try to make this video as short as possible. Okay. So let f is given by this uh, equation or this vector. So we have 4ev u square v 5u and euv. So you can see that the difference from this example and the previous example is that this example contain more variable. In fact, we have two variable over here, and we also can use this. We also can find the partial derivative of f over here. For example, we want to compute the derivative of f with respect to u. So first, we are going to compute the derivative one by one with respect to ith component, jth component, and also kth component. So if you compute with respect to u, so means that for uv, a derivative with respect to u means that we go to 4v. And this part, the derivative with respect to u, we need to treat v as constant, differentiate our u square, so is equal to 2uv, and this 5u is equal to 5. And over here, do the same process, we will get this answer. Okay, now let's say that we want to compute this part. F u, and next one is v. So differentiate this part with respect to v is equal to 4, and differentiate with respect to v over here is equal to 2u. Sorry, this part should be equal to 0. There is no more negative 5. So this is the right one. So differentiate negative 5 with respect to v is equal to 0. So this part should be equal to minus 0. And here is going to be what we call, is going to be a product rule. So product rule, I already explained how to use the product rule, and you can try to do on your own to get this answer. So this is a final answer for partial derivative of u, and then with respect to v, f u v. Okay, so done with this partial derivative. Next one, we are going to continue with the vector integral. So there are two type of vector integral over here. It is the same what we have in the normal integral. First one, we call it as indeterminate vector integral, where we don't have any limits over here. And next one, we have the definite integral, where we have the limits a and b. Okay, so this vector integral we can compute by the following way. The integral of RT is equal to integral of FT, integral of GT, integral of HT. So in other words, we need to integrate, or we need to evaluate one by one integral of F, integral of G, and also integral of HT. But keep in your mind, when we consider the indefinite integral, we have to add a constant. So a constant here must be a constant of vector, not a normal constant. So means that for ith component, it has its own constant together with j, and also kth component, it has to be its own constant. So C1, C2, C3. So after this, we are going to look how to compute the integral of a vector. Then the definite integral is given by the following one. So if we have a value, or if we have the limits on the integral, what we need to do, we just add the limits and compute the integral as usual. And then after we compute the integral as usual, we need to substitute the value of a and b. So as usual, we took b minus with a. Substitute with b, and minus with the substitution with respect to a. So what is the main difference between indefinite integral and also definite integral? It's just only this part. For definite integral, we don't have the constant c, so you can ignore what the constant c, just need to substitute the value of a and b. Okay, so let us see one example on how to compute the integral of a vector. For example, we have integration of indefinite integral cos pi t, sine pi t, and t. So integration of this one. So therefore, I write one by one for you. So integration of cos t. So this is the first integration. So next one, it is integration of sine pi t from here. And last one, integration of t from over here. So I divide into I'm divide into each of the component. Ith component, jth component, and also kth component. So integrating of this one, I will have cos pi t is equal to sine pi t over pi over here. Okay, but you have to keep your mind, we always have a constant over here. So means that here, after you do the integration, you need to add the constant with respect to ith component. And then integrating sine pi t is equal to negative cos pi t over pi plus cos plus c 2. So we need to add the constant with respect to j's component and t square over t c square. So this I add in another constant with respect to the k's component. So this is the final answer for the first derivative. Okay, the second question. Second question is definite integral. We have the limits over here. So as usual, compute the limits one by one. 1 minus t square, negative 4t power of 4, and then negative t square minus 1. So the integrating 1 t square is equal to t plus t cubed over 3. So we have limits from 1 and 2 for ith component. So keep in your mind, you have ith component, j component, and kth component. So you cannot combine everything. So that's why we need to do one by one. So over here, I missed some information here. So there will be j and also kth component. Okay. So the others, you can repeat the same thing. For example, differentiation, integrating negative 4t power of 4 is equal to negative 4 over 5t power of 5. And this part also the same thing. So the others from here to here, you can use the same step as you learned previously. Substituting the value of 2 first into the t, and then minus with the substituting the value of 1 into the t over here. So we have I component, j's component, and also kth component here. So you can double check my calculation here, and we have the final answer is given by the following one. So you always can pause the video and try to do on your own. Try to double check my calculation over here. Okay, so done with the integration. Okay, so now let us continue last part of this video. So tangent, unit tangent, and also unit normal vector. So these are three things that you have to know. So tangent vector is equal to derivative, first derivative of RT. And unit tangent vector is given by this symbol, t hat of t. So it is coming from the your tangent here. So this is your tangent. This is your t tangent, and this is the norm. This is the norm of your tangent t. Okay, and then the principal unit vector is equal to is given by the n hat of t, and it is given by the derivative, the first derivative of the tangent t, divide by the norm of the first derivative of tangent t. So let us look one example regarding all these three term, or all the three uh, what we call here, or the three component here: tangent vector, unit tangent vector, and also principal unit normal vector. So first one, let us given our let us given our uh, okay, so let us given our r is given by the following uh, uh, following equation: 4 cos t, 4 sin t, plus 3t. So in order to find t hat here, so let us look again the formula. So to find the t hat, we need to find the first derivative, or in other words, we need to find the tangent vector. So given t, I can find the tangent vector by the differentiating all the component here. So differentiating cos, we become negative 4 sin t. Differentiating 4 sin t is equal to 4 cos t. Differentiating 3t is equal to 3 over here. And then after I get the tangent vector, I can normalize it. to be like this, t over norm of t, like this. Okay, so first one, I already have my tangent vector over here, and I will calculate the norm of t, or the tangent vector. So to calculate the norm is equivalent to this formula. So square root of i's component, this is i's component, this is j's component, then this is k's component. So each of the component you need to take it square over here. So you have to keep in your mind to take the square. So here I would like to stress something that you just need to take the value over here. Do not take together with the vector. Some students, they will do mistake. They take the vector together like that. I, J, and K. So he or she will face some difficulty when computing the integration, the what we call the norm over here. Okay, so compute this one as usual. So you know what to do from here, and after some simplification over here, this 4, take it square, sine square become 16 sine square t, 16 cos square t plus 9, and take out 16. So we left with inside the bracket sine square t plus cos square t. It is equivalent to 1. And we have 16 multiplied by 1 plus 9. It is equal to 20, square root of 25. It is equal to 5. So therefore, the unit vector, sorry, the what we call here, the tangent, unit tangent here. So the unit tangent is given by this tangent divide everything with 5. So that's why I will have 4 negative 4 over 5 sine t, 4 over 5 cos t, and 3 over 5 cos t. So basically just divide everything here by 5 and also by 5 value from here. So this is called the unit normal tangent. So, if the question asks you to find the value of t hat at t prime, so you just need to substitute the value of t of pi over here. So I'm not going to do in this video. So you can do on your own. So just replace pi and pi over here. So pi sine pi is equal to 0, cos pi is equal to negative 1. So 3 over 5. So the final answer should be negative 4 over 5. J plus 3 over 5. Okay. Okay. Last one. So in order to find the value of normal tangent, unit normal tangent, sorry, normal vector. So to find the principal normal vector, this is a formula. From the unit normal tangent, we need to find the first derivative and then find the corresponding of the what we call here, the norm here. So t so the from here I compute the derivative to get this value. So keep in your mind, do not compute from the what you already substitute t equal to pi, or else you will get everything will become 0. But instead, you must compute from the equation over here. Okay, so differentiating this t hat t is equal to this part. So differentiating of sine, we become cos. Differentiating of cos, we become sine. And differentiating of 3 over 5, we become equal to 0. Okay, so after substituting, after differentiating this one, we are going to find the corresponding value of the norm. So as usual, take the square root and square each of the component. So ith component, jth component, of course we have kth component, which is equal to 0, but no need to write because 0 squared is equal to 0. And one more time, I would like to remind you, do not take the ith, jth, and component inside your square here. So it will be totally wrong. So just take the constant or the coefficient in front of ith component and jth component. Then compute everything. Simplified, you will get 4 over 5. So after getting the value, so of course we divide everything with 4 over 5, divide this 4 over 5, divide this 4 over 5. Then we will have this as your final answer. So of course, based on the question, you need to replace t is equal to pi t. So again, replace here pi t, and last one you will get I only. So the final answer should, after you replacing the value t equal to pi, you will get I. So j is equal to, for j's component is equal to 0. So thank you for watching. I think that's all for this video.